Imagine it's a calm day. The sky looks normal. People go about their routines, unaware that something dangerous is approaching. But somewhere nearby, birds suddenly fall silent. Dogs begin to whine and pace. Cows refuse to move. Fish dive deep or leap wildly from the water. Long before humans sense anything is wrong, animals already know. For centuries, people have reported strange animal behavior before earthquakes, tsunamis, volcanic eruptions, storms, and floods. Ancient Chinese records describe snakes leaving their burrows before major earthquakes. Greek historians wrote about rats, weasels, and snakes fleeing cities days before destructive tremors. In 1975, before the Haicheng earthquake in China, authorities noticed unusual animal behavior, snakes emerging from hibernation in winter, livestock acting agitated, rats abandoning buildings. Officials evacuated the city, saving thousands of lives. So how do animals know something we don't? The answer lies in senses humans either lack or barely use, and in survival instincts sharpened by millions of years of evolution. One of the most studied examples is earthquakes. Humans detect earthquakes only when seismic waves reach us, but animals may sense the earliest signals, known as P waves. These waves travel faster than the destructive S waves and surface waves, but they are too subtle for humans to notice. Many animals, however, are extremely sensitive to vibrations. Dogs, cats, rodents, insects, and reptiles can detect minute ground movements through their paws, claws, or bodies. To them, the ground may feel wrong long before humans realize anything is happening. Beyond vibrations, earthquakes also change the environment in invisible ways. As stress builds in rocks underground, they release charged particles into the air, ionizing it. This process can create subtle electrical changes and even produce ozone-like smells. Animals with heightened senses of smell, such as dogs and rodents, may detect these chemical changes hours or days before a quake. Some scientists also believe animals can sense shifts in Earth's electromagnetic field caused by tectonic stress. Birds, fish, and insects are particularly sensitive to electromagnetic cues because many species rely on Earth's magnetic field for navigation. Then there is water. Groundwater chemistry often changes before earthquakes. Rocks under pressure can release gases like radon into water sources. Amphibians, such as frogs and toads, are extremely sensitive to changes in water chemistry. In 2009, researchers observed that toads abandoned their breeding sites days before a major earthquake in Italy. These toads didn't return until after the seismic activity had ended. Tsunamis offer another striking example of animal foresight. During the devastating Indian Ocean tsunami in 2004, many wild and domestic animals reportedly fled inland before the waves struck. Elephants broke free from restraints and ran to higher ground. Dogs refused to go outside. Flamingos abandoned low-lying areas. Very few animal carcasses were found compared to the massive human death toll. Tsunamis generate powerful low-frequency sound waves called infrasound as they travel across the ocean. Humans cannot hear infrasound, but many animals can. Elephants use infrasound to communicate over long distances, and whales and dolphins rely on it for navigation. As a tsunami forms far offshore, it produces these deep vibrations that travel faster than the wave itself. Animals that detect infrasound may sense danger long before the water visibly retreats or surges. Changes in water pressure and salinity may also play a role. Fish often dive deeper or behave erratically before tsunamis. Sharks, for example, can sense tiny electrical fields and pressure changes in water. These cues may signal an abnormal disturbance long before it becomes obvious to humans on land. Volcanic eruptions provide yet another example. Before eruptions, volcanoes release gases like sulfur dioxide and carbon dioxide. Humans can smell strong sulfur odors only when concentrations are high, but animals can detect much lower levels. Birds often abandon volcanic areas days before eruptions. Small mammals leave their burrows. Even insects change their activity patterns. These animals aren't predicting the eruption in a conscious sense. They are responding to environmental signals that their bodies interpret as danger. Storms and hurricanes also trigger early animal reactions. Many animals become restless or seek shelter hours or even days before severe weather hits. Birds may stop flying and perch low to the ground. Cows often lie down. Dogs and cats may hide or cling to their owners. These behaviors are linked to changes in barometric pressure. As a storm approaches, air pressure drops. Humans can sometimes feel this as headaches or joint pain, but animals are far more sensitive to it. A sudden drop in pressure can signal incoming heavy rain, strong winds, or flooding, prompting animals to prepare. Marine animals show especially dramatic responses to pressure changes. Dolphins and whales may change migration routes or dive deeper before storms. Crabs and shellfish often bury themselves more deeply in sand. These behaviors reduce the risk of being tossed around by turbulent waters. Floods present a mix of cues: rising groundwater, changes in soil moisture, shifts in river flow, and altered scents carried by the wind. Ants, for example, are known to build higher mounds or evacuate areas before floods. Their sensitivity to moisture and vibration helps them anticipate danger. Rodents and snakes often move to higher ground well before floodwaters arrive, sometimes leading humans to misinterpret their appearance as a sudden invasion, when in reality the animals are simply escaping. Even fires can be sensed early by animals. Subtle changes in air quality, temperature, and smell can alert animals before flames are visible. Birds may suddenly take flight, and larger mammals may flee areas that seem calm to humans. Some insects can detect infrared radiation from fires miles away, allowing them to escape or, in some cases, exploit burned landscapes for breeding. What ties all of this together is not prediction in a human sense, but perception. Animals do not foresee disasters the way weather forecasters or seismologists do. Instead, they respond instantly to environmental changes that humans either ignore or cannot detect. Their nervous systems are tuned to survival, not convenience. Over evolutionary time, animals that reacted early to danger were more likely to survive and pass on their genes. Humans, by contrast, rely heavily on technology and conscious analysis. We have instruments that can detect seismic activity, atmospheric changes, and ocean movements with incredible precision. But without those tools, our natural senses are relatively dull. We also tend to rationalize away subtle warning signs, trusting routines and assumptions instead of instinct. Scientists today are studying animal behavior as a potential early warning system. While it's unlikely animals alone could provide precise predictions, combining behavioral observations with modern sensors may improve disaster preparedness. Motion tracking livestock, monitoring bird migration changes, and observing marine animal movements could add valuable data to existing systems. Still, there are challenges. Animal behavior can be influenced by many factors: predators, weather changes, human activity, making it difficult to separate true disaster signals from normal variation. That's why scientists caution against relying solely on anecdotal reports. Yet the consistency of these stories across cultures and centuries suggests there is something real happening beneath the surface. Perhaps the most important lesson is humility. Animals remind us that the world is full of signals we no longer notice. The ground speaks. The air changes, the water shifts. Animals listen because their lives depend on it. Next time you see your pet acting strangely for no obvious reason, it might not be random. It could be responding to a message written into the fabric of nature itself, one that humans are still learning how to read.